Go ahead and get started. I'll share my screen. So as a reminder, this meeting is public, recorded, and published on YouTube. If you have anything that you want to discuss, feel free to add it to the agenda document. It's linked on the calendar invite. Looks like we've got a handful of items today. So let's get started. First item, Vladimir added an item about passing specific metadata through I believe it's the node publish call of the create volume request. Does anybody want to talk to this issue?
Well, I'm present, Saad. So basically, somebody had reached out on the CSI SIG, or actually it was the working group channel, and brought this to our attention. And what the person is looking for is a way to forward to the driver CO specific data. And in this particular instance, the author of the issue is, I guess, is writing an external driver and pointing out that in past or in internal, when we used to have internal drivers, you used to be able to get PV informations, but now that information is not making it all the way through to external drivers. So this whole issue is basically a discussion of whether or not CSI should accommodate that request.
Well, there's another way to look at this, which is, individual COs like Kubernetes could decide to pass these things down as metadata if they choose to, and then drivers could consume that. The question is, does there need to be a standard at the CSI level for how that should look, or can it just be metadata that's added onto all the other metadata?
Yeah, I agree with Ben here. I think on the create volume side, we've designed the parameters to be opaque, and whatever requirements you need that don't need to be codified into the spec, you can basically put them in the parameters as a list of things that your plugin requires. So if your plugin requires workload information and it's going to be specific to Kubernetes, what you can do is in your parameters list have pod UID or pod name or whatever be one of the parameters that you accept. And you're basically saying that I am going to be a volume driver that only Kubernetes will understand. And then the sidecar containers that you use to deploy within Kubernetes should understand how to basically set those parameters correctly. So I think on the create volume request side, I don't think this needs to be codified into the CSI spec. I agree with G's comment below that if we start doing that, we start leaking, making a leaky abstraction essentially.
Absolutely.
Now, there was another variant of this issue that I encountered earlier this week. So there's, in Kubernetes, ideally we want CSI to become the de facto way that volume plugins are done. The flavor of volume plugins that we've been focusing on so far has been remote volume plugins. And those, I think, for the most part, we have a good handle with the current iteration of CSI. Things seem to be working fairly well, and I think the issue pointed out here we can work around with sidecar containers and parameters.
So, if I may for a second,
sure.
the wording of the spec says the parameters will be opaque to the CO. So that means that like the CO should not be setting them actually.
Right, the CO itself doesn't need to set those, but the sidecar container need not be opaque, right? You could have a sidecar container that's specific to your plugin, and it can basically set the correct variables. Essentially, you have a sidecar container, an external provisioner that understands that it's talking to your plugin and understands the requirements for your plugin and can probe for that information.
But some of that might not be probable from a sidecar. For instance, if you want to know which container has a mount attached to it and providing some UUID for that container, so you can do some post-processing on the container after the thing's mounted, that's a little difficult.
So that's actually what I was going to talk about next, Brad. So I think on the create volume side, it's not so much an issue because you have these opaque parameters, but on the mount side, on the node publish side, it actually becomes problematic because CSI doesn't provide a way for workload information to be propagated to the volume plugin. There are a class of volume plugins, for example, ephemeral volume plugins, where their lifecycle is tied to the lifecycle of the workload. This is things like in Kubernetes, we have secret volumes, config map volumes. In the future, we'd like to do injected identity volumes that will take like a Kerbos identity and inject that into the pod when the pod is created and delete that when the pod is deleted. In those cases, the identity of the pod, the workload, is important, and we have really no way of surfacing that within Kubernetes or within the plugin, within a CSI plugin, because the CSI interface doesn't actually allow a way to be able to surface that.
But
I don't know. Sorry, go ahead.
No, the question was, would these type of volumes be externalized as CSI volumes? The three that you mentioned?
Yes, some of them would. So for example, if you want to have some sort of third-party key management system and you want to be able to use that to do identity injection into a pod.
I see.
Right, that's not something that would be an in-tree volume plugin. In Kubernetes, ideally, it should be an external plugin. And for external volume plugins, CSI is kind of the way that we want to go.
Right.
But we do have this limitation. That said, I don't want to, if at all possible, pollute the CSI interface with CO-specific things. So either let's figure out a way to be able to do this generically, or best case scenario, if we can handle this in sidecar containers somehow on the CO side, that would be ideal. I haven't thought through all the possible solutions, but I agree that a variant of this issue does exist and we should take a look at it.
I think it's just an enhancement to the metadata handling, right? We just need some mechanism for COs to push metadata to the CSI driver, and we don't try to define what that metadata is. We just allow for it.
The problem is that if we have a metadata opaque set of labels or string map that we pass through, what are the requirements on that and who is going to set it?
Well, this CO sets it to whatever they want. It's just metadata. And you could look at it as, there's probably some enhancements for each CO that the CSI driver could achieve. And there's things that one CO might have and another might not.
Yeah.
So
what this reminds me of is in the HTTP protocol, there's a way to be able to surface what the client is to the server. So things like browser information. This seems very similar, but the scary thing about that was it leads to huge, huge fragmentation where you start having servers that'll say, if Internet Explorer, then do this. If,
No, I agree. So that is one downside of it for sure. But we've already encountered, there's been multiple people that have come in and said, hey, we want to write a CSI driver. We want to start off in Kubernetes. We want to make, we want to enable some optimizations and some performance that are specific to Kubernetes architecture. When we go to Mesos or Docker, we're going to enable specific optimizations there as well. But we don't want to make one that just works with everything because it's not going to be as performant as if we had special optimizations for each.
Yeah, I agree.
That sounds exactly like Saad's web browser example, actually.
It is. I mean, it's not ideal, but it is what it is, right? I mean, each CO has functions, and we can't come up with a superset of every function.
Yeah, my suggestion will be like, if there's any common things that we can think about, and I would rather much prefer to first class those things on the CSI spec versus having those free-form key value pairs. I think one of the lessons we learn, like, I mean, if the browser is probably like too far away, like one of the lessons we learn is like, take CNI as an example. Like CNI do support those vendor specific, or like, sorry, like CO specific labels, which cause a lot of pain for network vendors because they have to write specific logic for different COs. We need to be cautious on that. I mean, I would rather just think about, is there any common things we can do in first class?
So one benefit of having opaque metadata to start with is you don't have any API requirements for it. You know, it's kind of up to the plugin to implement it. If it breaks later, it's too bad.
But then it becomes an undocumented API essentially, right?
So what I'm saying is, like, as the stuff firms up in your opaque metadata, then you move it into true API and have real API calls for it. You just say,
so what we're asking for here is uniquely specific to Kubernetes, right?
What's uniquely specific?
Pod UID, pod name, that kind of thing.
Yeah, exactly. But a lot of these integrations we're talking about, I mean, if we're talking about a Kerberos sidecar that does injection of credentials, it's going to be Kubernetes specific. You know, there's not, that's the CSI.
Right. I mean, there's no argument that there will always be Kubernetes specific volume plugins, but whether the CSI interface should allow for Kubernetes specific parameters, I think we should avoid that at all costs.
What has to? I mean, if you're saying that a plugin can be specific to a CO, there has to be some allotment or some consideration.
Well, I mean, so this was kind of the what people said about the create volume side, right? People said that you can't have specific parameters that are specific to a particular volume plugin, and you know, how do you do that? And we came up with the opaque parameters as a mechanism to allow for that. I wonder if something similar on the mount side would be useful, where you have a set of opaque parameters that a plugin can require. The challenge is, how does that get set? On the create volume side, we leave it to the end user to be able to specify that. On the mount side, it becomes more challenging because ideally you don't want the intervention of an end user to be able to do the mounting. Really what we're looking for is a way for the CO to be able to recognize what these parameters are and say, oh, I know what that is. Let me fill that in.
Well, right, and having them opaque is beneficial in multiple scenarios. I mean, it's like mount options. You know, sometimes you may want to set a cache size for your, you know, for a particular mount that it may be just specific to one CO. You know, and having those hints provided as part of the mount call, you know, a plugin doesn't necessarily have to act on them. It could just be metadata.
Could we do some sort of system where on as part of capabilities, a plugin says, I require, you know, parameters foo and bar?
Well, I don't think these are required parameters. I think that's kind of the point, is like these parameters shouldn't be required or forced on the plugin. It's just metadata and hints that the CO is providing that some plugins may be able to take advantage of.
Well, no, I mean, so in specific, for specific plugins like the identity injection example that we were talking about, these are a requirement. If they don't have workload information, that plugin will not work.
So what I was going to say, this has been, I see a difference between like plugin specific options and CO specific options. Plugin specific options are bad because they let someone who's writing a driver create a situation where like COs have to do something ugly and they can cause harm. So then you have plugins causing harm to the COs. The case that we're talking about, where COs may pass down extra parameters that plugins may depend on, if plugins decide to depend on those parameters, they're hurting nobody but themselves. The plugin is the only thing that is damaged by the dependency on some parameter which might not be present when some other CO is used.
Yeah.
So I don't think it's as harmful to let plugins or to let COs pass CO specific things in, and then a good plugin would never look at that stuff. But if for whatever reason a plugin wanted to look at that stuff, it would be limiting itself by tying itself to that CO. That doesn't seem quite so bad to me.
So Saad, your previous point was to use the capability to specify to the CO.
Well, I was thinking, you know, what I don't like about Ben's proposal there is it becomes an implicit API, right? Because you have a volume plugin that's depending on behavior that may or you know, parameters that may or may not be passed in by the CO. And I much prefer a concrete API rather than something that's implicit. And so I was thinking maybe the plugin actually says I expect, parameters A, B, and C. And if a CO understands what parameter A, B, and C are, then it must pass those in. If it doesn't understand what parameters,
so the API is only implicit on the CSI side of things. From the Kubernetes side, we would be explicit about the API because we'd have explicit plugins that use that API.
But essentially what we're saying is that implicitly Kubernetes must always pass in workload information as metadata.
Well, and that's fair. I mean, there's
right? Like what is the full set of information that Kubernetes must pass in? How do we codify that in the API or in the CSI spec?
Well, we don't. We just leave it open. It's
so
just
then it becomes an implicit API, right? Now you have a set of parameters that Kubernetes will pass in, but it's not really part of the CSI spec.
That's true. We made that concession in other places too, where we have opaque metadata. Having implicit API in the spec, the CSI spec, isn't necessarily a bad thing. It's
so the opaque parameters that we have on the create volume side, they still have a way to be able to, for someone to specify what the parameters are, right? The plugin says, I expect these parameters to exist, and then all COs must provide those parameters when they create that volume.
And I would further add that those opaque parameters, those are not CO parameters. Those are
right.
Storage backend parameters, right? We actually don't have anything that's opaque that's like, this is from the CO, right? So this is actually quite a change to add something like that.
So that's just going back to create volume, like those, we agree that this, like the sidecar container will set it, but the sidecar container in a CO is an implementation detail. Actually, it's like, I mean, technically we are saying that this opaque parameter will be set by the CO in the create volume.
It may be on the Kubernetes side, it's not, but the point is that they're not CO specific. They don't have to be CO specific. They can be if they want to, but they're not,
But it is like, how do I say? It's just that it is something CO is setting, like whichever way the sidecar container or Mesos or Docker does it a different way. But we are basically, we cannot use the language that we have used in the spec, and let the CO set the value, those parameters in the create volume call, right?
The important distinction is the Kubernetes core binaries that are shipped setting something versus a sidecar container, which may be created by the plugin vendor, right?
These are semantical issues, though. We have sidecars for all of our kubecsi bridge. Right?
Yeah,
so every sidecar is still part of this kubecsi bridge.
Right, and you can always swap those out with your own sidecar container.
But they're Kubernetes specific, actually. Like all the sidecar containers will be, and like
we provide a set of generic Kubernetes sidecar containers that you can use for an off-the-shelf plugin. But if you have any sort of custom logic, which would be the case here, you can always replace those components with your own components.
So we're not trying to say that we want to enumerate what the list of properties are coming from a CO, because that's not possible, right? I mean, Kubernetes is going to have pods. Docker is just going to have containers. I'm not sure what Mesos uses, but it's going to be called something different. Mm-hmm. Whatever that data is that's coming out of the CO that we want to make available to the CSI plugins is never going to be the same. It's always going to be different depending on the CO, right? And we could say, well, we'll have a sidecar that sets the data, but we still have to have some mechanism where they can pass the data through. And that's all that we really need, is like that little pipe that the sidecar or the CO.
I think we're in agreement that, yes, that is the problem for the mount side. I don't think that's the problem for the create side.
Right, and I don't think create's as big of an issue here.
Yeah, I agree.
No, I think that, sorry, I think that this is like the create and publish both has similar. I just do not necessarily agree that the just because there's a sidecar container setting up in this case, for example, our need is to set the PVC name, PVC label, so that in the cloud interface we could identify that this volume was provisioned.
So, Hamas, the way that I see it is, if your plugin has a requirement for example, the PVC name on the create volume side, there is a way to make that work today, versus if your plugin has a requirement for the pod name on the mount side, there's no way to make that work today.
Can you not, like, in that case as well, like one can very well like I would say that abuse maybe the volume attributes that we pass on the node publish, because it's.
I was thinking about that, but I think the problem is, how would you even do that? Like, there is no sidecar container on the mount side.
Exactly. That's what I was saying, Saad, that this is like, we happen to have a sidecar container in the on the provisioning side. It's just implementation detail. In Kubernetes, we don't have a sidecar container on the node side. But if we had to, like, for example, if like the inbuilt kubelet itself like extracts and passes those values to the volume attributes as we do for Flex right now, it's possible, unless like the specs say the volume attributes must match what is returned by the volume in the when we create call is made. So
just a thought that, can you add those, like say you have some information you pass from create volume to the plugin, and plugin just attach the same information, the volume attributes to the CO. Can we do that? Does that solve the issue?
Sorry, say that again.
So basically you attach whatever the parameter that CO passed to the plugin to the volume attributes, including.
Yeah, I was thinking about that just now, because volume attributes is kind of our opaque field. Do we have any requirements around volume attributes only being present if the create call is returns volume attributes? I think we might have language that basically says this must be exactly what the plugin returns on the create volume call or something.
I think you
So
can
it's right
still
above,
maintain
right?
that. You can still maintain that environment, just like during create, you attach whatever the CO specific parameter to the volume attributes.
I mean, ideally, we want these kinds of plugins not even to have a provision call.
I see. Okay, so you want to avoid the provision call, but still want to have.
Yeah, they don't even have a control plane. They only have a node component that does a mount, and then the mount says, "Oh, I see that you are trying to, do this particular identity for this particular pod. I will ensure that I go and fetch that identity and make it available for this pod."
I was wondering, like, for this particular use case, maybe one route forward is trying to define this workload, like more formally in the spec, and then like dictate CO has to pass some workload specific information during publish.
Well, part of it's the pod identity, right? I don't think there's a generic pod identity across all these COs.
I think that's the reason we call it workload in the spec right now, that it's going to be pod in Kubernetes, it's going to be container in Docker. And it might be something else in Cloud Foundry or Mesos. So,
I would much prefer that path to essentially making opaque pipes through the plugin. If we can.
So what about, so you get to like a many-to-one issue sometimes. I mean, you could have a volume that has multiple containers, pods, workloads, whatever associated with it.
I mean, is this only a Kubernetes integration problem, or is this something that is going to be a problem for Mesos too?
I don't know. Do you guys have a need for plugins that will, for example, inject identity for the duration of a workload?
we don't have that requirement right now.
But if it is something that Mesos and other COs are interested in, then I think it might be worth doing what G suggested, which is establishing this as a more generic type of plugin and coming up with a set of fields that are specific to handle that.
Yeah, I think we're over-engineering that. I mean, I think it could just be as simple as allowing some metadata.
I think that one problem is, like I see, is like if we don't put something in the specs, then then people will just use like whatever is available, like the volume attributes in this case, and in the create volume, the opaque field that is present. So it's not coded that like how we validate these fields. So the plugin implementation could potentially pass anything they want, pretty much. So
well, the CO could. The CO is passing the information down, and that's fine. The CO would create its own API, explicit API.
No, I'm saying that the danger of not having an explicit way is like the plugins reusing existing fields that exist on the node publish and the create volume, and like implementing this in an ad hoc way that and making the plugin anyway dependent on a CO implementation. So
that's what we're talking about, is plugins that are already dependent on. I mean, all the plugins that we're concerned about right now are Kubernetes specific plugins that are going to be dependent on Kubernetes, and we would establish an API for the metadata coming from Kubernetes to those plugins.
So are we saying to basically create another something that's similar to volume attribute, but specifically for workload, to push workload information to the driver?
No, I don't have a concrete idea yet, but I think one of the things that we realized that it would be nice that the CSI formally define what that means for a workload. I think we have this term in the spec, but we don't really formally define this in first class in the field, like workload specific fields for those calls. I think maybe one of the approach to just first class the workload concept in CSI, and then CO can decide what to do to define their definition of workload.
Mm-hmm.
And maybe we can figure out some way, maybe just a string or like a map of string to string. We can decide that later. That's just one direction I was thinking. Haven't flushed this out yet, but that's something that we realized during the implementation too, that it would be nice to have some concept of workload in the spec. It's pretty vague right now.
I wonder if it would be useful in other places as well in the spec.
Because I think the publish itself is actually for a given workload.
Right.
So it's kind of pretty natural to define what does that mean for a workload.
Node publish, right?
Yeah, no, that's pretty like specific for a workload. So I mean, that's just my thoughts.
Right.
Yeah, I like that.
I mean, I hesitate to bring this up, but there's already a backdoor that you can use in gRPC, right? Like you could pass context metadata. That's just, it's kind of like sideband, right? It's not really part of the CSI spec.
Yeah, but I think the point here is let's try to avoid that route. I mean, I would rather just prefer a first class route to solve that issue versus gRPC extensions or some other extension mechanisms.
Which makes it easy to document.
Well,
I think we're in agreement.
So how deep down the workload definition do we want to go? I mean, are we going to try to define all that characteristics of a workload, or just leave it as, a place that people can put?
I think that would be CO specific, right?
Right.
Yeah, it's going to be CO specific, something that we can do. For example, you can have some identifier or enum type for CO kind, and then the format will be up to the CO to define that format. And the plugin have to know about those kind and do specific things regarding the workload fields. Something like this.
Aren't you back at this same idea of the volume attributes there, that it's very generic? I mean, then you just name one thing to the other.
I think the difference is that volume attributes has been designed as a field that the CO should not muck with, whereas this field would be something that we explicitly say is going to be set by the CO, and will be, the format of it will be designated by the CO.
Oh, so we just have string coming from the CO.
From the CO, right.
That sounds great. That sounds perfect.
But as soon as you do that, the problem will be, what information do you include? Does a CO include?
Right. We need to scope it down in the language to say this is information that will uniquely identify a workload. For Kubernetes, that could include pod namespace, pod name, pod UID. For Docker, it could be the container ID. For Mesos, it could be whatever the unique workload identifier is. And then if in the future we identify another set of things that need to be pushed down from the CO, we will need to look at those independently. So this doesn't just become an opaque hole that you can pass anything through. It's kind of bounded, and it says it should only be used for this purpose.
Yeah, I think I like that part, especially because like in the future, if we find out there is some common fields that the CO can agree on regarding the workload, then we can just pull that out into a first class field inside that workload ID thing. It's kind of gradually like from a free form key value pair to some a bunch of first-class things that every CEO will adapt to, which is a nice thing for plugging anyway in the future.
Yeah, I love this design.
Who wants to take this on?
Well, just a question. It sounds like this is intended for, at least initially, plugins that are targeted to a single CO. Is that the goal?
Initially, yes, but potentially in the future, it could be multiple COs by having if-else logic that will.
Yeah.
Well, it's either that or else we find some commonality that we bubble up into the formalized API.
Right.
Yeah, I mean, I'd like, however we, if we decide to pursue this path, I mean, I'd like some kind of language that somehow indicates that, this should really only be used for CO-specific plugins until there's at least some first-class fields there, right? That we can reason about.
Yeah.
What I don't want is I don't want someone shipping plugins with all this crazy if-else logic that we talked about. That just sounds insane. So.
Yep.
So having said that, then wouldn't it be better to kind of take a slow approach where you can get by today with the volume attributes, and over time, as we identify common attributes across the COs, you start defining them into the API.
I don't think we can get by with the volume attributes because it explicitly says we're not supposed to set them from the CO. Right?
The problem with the volume attributes is that when does the CO decide to inject its own set of volume attributes and when does it not?
And how to avoid overriding whatever the provider, I mean, in this case, if you're writing a specific CO,
Sorry, you broke up a little. Could you repeat that?
Well, I was thinking that how would you avoid overwriting an existing attribute unless you had full control of the end-to-end pipeline.
The purpose of volume attributes is essentially as a cookie from the plugin back to the plugin, or for a end user who understands what the plugin parameters are explicitly to set them. The CO should not be mucking with it for exactly the reasons James mentioned, which is you can override a parameter or set a parameter that the plugin doesn't expect. So I'd prefer.
I understood. I was just trying to think of same thing that I think was James was saying. The concern being you create the conditions for people to create specialized drivers and start with the if else for every CO, and then getting them out of that later is going to be more difficult when you actually find the attributes, the common attributes.
Yeah. So far, we don't have a client ID, so technically you couldn't do that even if you wanted to. So that helps.
Should we have something similar in Create as well, where the CO is pushing something, some metadata to the driver?
I'm going to say no. And the difference I see between volume attributes on the node publish side and parameters on the create volume side is volume attributes are intended to be created by the plugin and passed back as a cookie, whereas parameters are intended to be filled in by the caller. And the caller in the Kubernetes case is usually the cluster administrator, but theoretically it could be a sidecar container. But if we come up with a generic workload, and the other problem is that you may not have a workload on the create side to begin with, right? You could pre-provision a volume before you even have a workload.
Right. I was just thinking for symmetry.
Yeah. I prefer to start with just node publish, and then if needed, if it's absolutely unworkable, then add it into create volume. Start with something minimalistic and then expand.
So one thing that I'm concerned with is that even if we don't add like an explicit client ID, that some plugin is essentially going to use the workload fields as like the implicit client ID, right? Like, oh, if there's a pod ID present, then this must be Kubernetes, right, or something like that. So
Yeah.
I mean, I don't know how to avoid that, but it.
I don't think we can, because I mean it's up to the implementer of the driver to.
I think one idea is like in the workload ID, maybe introduce some field like first class field, like the CO identity, something like this, so that it's more programmable, like rather than just scan all the keys and find out, oh, this key exists only for Kubernetes, and do some Kubernetes specific logic.
Yeah, I don't think we can force people from, force them into the, away from bad behavior, right? They can figure out what platform they're on.
Right.
Well, I think we'd like to discourage bad behavior, right?
Yeah,
like
if
you can't twist anyone's arm, but you can maybe make it more painful to behave
Call them
badly.
some bad names.
I mean, this actually brings up something, which is for before 1.0, we're going to have to start talking about certification. What does it mean to be a certified CSI driver? And maybe, this could be somehow encoded into the certification process. Like if you are going to be a certified CSI driver, you don't engage in these set of bad behavior such as X, Y, and Z.
Yeah, how do you test that? Aside from a code review.
Yeah.
Right. Because I mean, if I put out a driver out there and it works fine with, Kates or Mesos, then I should be able to pass, right?
I mean, I think for CSI, a certified driver should be compatible with, multiple COs. We should say 2 or 3, or make some limit. And if it doesn't get that sticker. And the way that you test it is you have to be able to pass some set of tests by deploying it in both systems. And if you can't, then you don't get it. And if you are able to fulfill that with crazy if-else statements, yeah, you're right. You can't get around that.
Right.
This is a cheesy rat hole right here, right?
Yeah.
There's a lot of stuff. I would.
No pun intended.
Okay, so let's take it one step at a time. I think we're in agreement that being able to identify workloads in the node publish is important for a certain subset of volume plugins. We agree that a good way forward is to have a workload struct that is generally basically just a map initially that we can pass through. And then if there are fields in there that become obvious that they should belong to all COs, we can promote those fields in that struct in the future. And then we can talk about certification and all these other things in the future. Anybody disagree?
Yeah, that sounds good.
All right, cool. And who wants to pick up this work?
We can take it unless there's another volunteer.
Go for it.
Okay, cool. One thing I want to talk to or just comment on, I know for folks on the Kubernetes side, it sometimes gets a little bit frustrating when you hit issues like this. It feels like you're kind of chained at the foot. And it's like, we have this very clear need for a scenario that we want to solve. Why do we have to be chained with all the other COs? Ultimately, I think it helps us develop a better interface. It prevents us from making leaky abstractions. And so I think in the end, we end up with a more robust interface that's going to be more usable and probably last longer than if we didn't have these requirements. And in the past, I haven't seen it slow us down that much. So bear with the process. I know it kind of sucks, but I think in the end, it'll be worth it. All right, I think we can move on to the next item. Hamath, you want to talk about finalizing the resize?
Yeah, so I like just when I added this item, I saw 2 comments by James. I think I have addressed like all the comments except the comment that James added just now. So I would, if I may, I can just address it here. Like the first one is that if the volume, there would be always volume type that cannot be expanded when the volume is in use. And for that, there's an error I have added. If a volume cannot be expanded when in use, plugin should return failed precondition error. And CO should retry only after calling controller unpublished volume if plugin has published unpublished volume controller capability, right? So I think how like we might want to expand the error message if like if the volume is in use. In this case this was the comment that James has added for controller expand volume. So in most cases, if like that I know of, if there's a like yeah, so I think like we'll have to, how do I say it? I'll have to make this error message more specific, not just for controller published volume, because it could happen for something like GlusterFS. Although GlusterFS does support it, but GlusterFS will not have a controller published volume. So like imagining a volume type like that. So I'll just expand that error messaging, what to do when that happens. And the second comment that James has is that node expand volume must be called only on a volume which is already published by controller if controller has published unpublished volume capability. So I do not, I think, understand that comment very well, because like under what cases that capability isn't supported though. So in that case, like the node expand volume can be called anytime, right, James? Like, can you just elaborate on that one? Or
Yeah, well, so I was reading your PR, and there was there's this condition that node expand volume must be called after controller expand volume. Sorry, no, it's node expand volume must be called only on a volume which is already published by a controller, if that controller has published unpublished volume capability. But again, like if the controller doesn't have that capability,
then that condition does not apply to this thing, and then they can call like whenever they want, right? So like, why is that a problem? Just trying to understand. So like, for example, like let's say again taking GlusterFS, around GlusterFS, but GlusterFS doesn't have a node expand volume. But let's say there's a iSCSI volume type, then it does not necessarily have a controller publish. Then the node expand can be called like anytime. It doesn't matter, right? Why is that? Like,
I guess I just don't really have it clear in my mind when maybe enough concrete use cases for when it's safe to call node expand, what state the volume must be in order for node expand volume to be called successfully. Like it's not clear to me based on what you've written here, like what that state is.
yeah, so I'll just I know if folks have read the updated proposal, but I've tried to avoid being being very specific that it must be called after node publish or node stage, and the reason is because it's like a controller. Sorry, it could be also used for online resizing, like volumes in use. So a node plugin must implement this. I'm just trying to read the node to expand volume, the new description. Node expand volume must be called after controller expand volume if volume has expand volume controller capability. Also, node expand volume must be called only on a volume which is already published by controller if controller has published unpublished volume capability. Node expand volume expects volume to be available on a specified volume path, and node expand volume itself will not implicitly call node stage volume or node published volume. So that's the wording that I have used, and the reason for it is like, rather than tying it like do this and then do this, I just wanted to make it clear to the plugin author that the node expand volume itself will not cause controller publish, or it will not cause node publish or node stage. So like the CO, CO is the one which will call this node expand volume, and CO has to ensure that the volume path that it is providing to the node expand volume request is available on the node. So yeah, I thought this was clear enough, but I don't know. But you see, I'm just trying to hesitant to put like a specific like node stage or node publish, because some volume types may not have node stage, or they may just implement node publish.
Okay, so yeah, I think I see the point you're making. I think what I would like to see then, because the way that it's written, it's not, at least upon first reading, it's not very clear what's expected of a CO. I would like to see some specific workflow examples called out. Like if CO wants to resize a volume, and let's say that the plugin supports X set of capabilities. Here's what a CO is. Here's what we expect a CO to do, right? And then and do that for a couple different permutations of capabilities, so that it's really clear what the expectations are. Because as it's written right now, it seems very loose. And and what you said, something that I keyed into what you said was, you wanted things to be very clear to a plugin, and I want things to be very clear to a CO. So, and I think we're not quite there yet.
Okay.
So, sorry. Another comments I want to add is that, by adding this node expand volume, we're not only, so now the CO is not just a scheduler that will set workload and schedule workload. Now, by calling this node, because CO need to call this node expand volume, it looks like the CO need to actively start a new some sort of task running on a specific node, and CO need to figure out, okay, which node I should run that like node expand volume to. So now it's generating a workload for itself. So I just feel it's not like doesn't fit to the role of CO very well.
I think that the intention was not to have the CO generate a workload just to expand the volume on the node. The idea was to wherever this workload is deployed, wherever this volume is being used in a workload, or like to be more specific in Kubernetes term, whichever pod is using this volume, the expand will happen on the volume expansion will happen on that node. So this that's why I tried to make this clear that this node expand volume itself will not cause control expand. So it's like, again, but it's possible that a CO may choose to implement a situation where it might want to schedule a workload just to expand the volume. I don't know if we should prevent that, by the way, but regardless, in the scenario that I had in my mind is like the workload is already scheduled, and wherever with the volume, and these calls will be node expand volume will be executed there. So it's like the way we do like node published volume or node stage volume will probably format the volume as well, right? In the case a workload wants to use a block device, it has to be formatted before the workload can consume it. So in similar way, like these calls will allow the volume to be, the file system to be resized before the workload can start using it. There's a subset of that feature that is that CO should be able to do this online even if the volume is in use. And but that's another case that I have tried to cover. So I'm not sure if like that is something we need to prevent or we need to say, but the scenario that I had in my mind was basically not to have the CO deploy this as a workload separately, but they could if they want to. I don't know if we should be stopping them from doing this. It's just that.
So that also means we cannot have another scenario that the operator want to actively expand the volume, right?
Sorry, can you say that again?
Then this won't support the other scenario that we may want to provide a functionality for the operator to directly expand the volume before he even schedule any workload.
This won't provide the functionality. Yeah, if the CO is not going to schedule a workload, then the resizing or the expansion will not be complete. And in that case, like that's why I don't want to be like my intention was not to be specific in the CSI side, like how will this look like. We have discussed this in Kubernetes, and we considered deploying a container like a daemon set where the volumes will be mounted and resized. But it's like it's up to the CO or up to the CO to decide how it wants to do this operation. I think but as it exists, like this spec does not prevent this. That's what I'm trying to tell you. Like the spec does not prevent someone from starting a workload to just resize the volume, and that's fine. But right now, the case I had in mind in Kubernetes, at least the way it will be, is like a workload must be deployed already, and how the scheduler handles that is like, I do not think it should be hard actually, and I do not think we need additional fields here because in that case, like the scheduler or the CO has to create a workload, like in case of Kubernetes standard pod definition, or in Docker the standard container, have this volume mounted within it, and then like do the resizing. So yeah, I'm just trying to think through that. It should not stop that case, but in the first pass in Kubernetes will not be doing like file system or the node size expand if the volume was not in use.
Yeah, so this is an example of something that I think deserves more discussion in the document, because it sounds like you've got some different cases in your head that there's detail in your head that just hasn't landed in the spec yet that would really help kind of illuminate this discussion. So.
All right. Okay. Perfect. So I will update the specs with the detail about like various use cases, or like the flow, like with maybe 2 or 3 different volume storage providers, and how it will look like, and make it more clear to the CO how the calls will be.
Yeah, that'd be great. And I think, just to be clear, I don't think I'm asking for like, the daemon set, things need to be deployed as a pod or a daemon set or something like that, but just even have an understanding of like state transitions for the volumes and things, right, would be helpful. And what's the expected CO behavior given some permutation of capabilities. So.
Yeah, that sounds good. Okay, no problem.
Thanks.
All right, so I think that's the last item we have time to discuss today. Let's table the rest of these for next week. Anything else anybody wants to talk about? We've got 3 minutes left. All right, thank you very much, and we'll reconvene next week, same time. Take care.
Thank you. Bye-bye.
Right. Thanks,
Bye.
everyone.
Thanks.